Let me go ahead and I'm going to pull up here just a quick example. So we've got here in our example for a general ledger data warehouse, we've got three different sets of approaches for fact tables. One is a GL detail fact. So this is kind of modeled around, if you think about your general ledger, where you're storing your transactions by date, right? But you want to go out there, documents and accounts and address and assets and unit measures, all these different type of things, companies and business units and subledgers and all of that data needs to be tied in. And then we've got all the time-based dimensions for things like GL date or batch date or whatever the dates that are associated with the warehouse. So the point of a star schema, again, if we go in here and look at this org dimension, we've got the different objects here, and then we've got these. In your case, let's say org segment 1 was division, and that would be obviously in your warehouse would be called a division. 2 might be region or line of business or whatever the meaningful names are for your specific organization. But the point here of when we actually, so a star schema means that you really have your fact table with one set of joins to your dimension tables, right? So that's kind of what it's defined more as the star. A snowflake would be where then, let's, for instance, under a JD Edwards direct scenario, you might be going from your general ledger to a business unit master table, and then you might be linking out to that to some other supplemental tables to go get or views to go get the user-defined code descriptions. So you actually end up having joins from your primary table to a secondary table to a third table. So once you get out to that third level, that's where now it's more of a snowflake design versus a star. So then it begs the question, okay, well, what's the difference? Does it make a difference in performance? And it all depends. But that's one of the beauties of the data warehouse is that the modeling of the data is much easier because each of these dimensions is already taking into account a lot of that logic. And that's why these semantic layers on top of the data warehouse may be much more intuitive to create and manage. But either way, if I go down here, well, we'll show you in the other one. The next one, which is another fact table that we deliver, is our summary fact. And this is now a table that's very similar to your account balance file in JD Edwards, where you're actually getting one row per year per account and all the other unique records there. Still taking advantage of all the surrogate keys, star schema, and everything like that, so you don't have to go and add all the extra layers. But what we introduce as well is kind of another fact table, which actually kind of pivots your balance file in JD Edwards, so you're actually getting 12 rows for each account or each detail which would be on the summary. So this is actually the summary fact table has one row for each year, whereas if I go and show you the last one, the balances fact, this actually has one row for each period and year. And so now they actually add, in this case, there'd be another period dimension that would be available now that would have some other object that will allow you to do more analysis on, where you can specify specific fields within the period. And that's one of the difficulties about sometimes on the financial analysis. Your general ledger may have too much detail, too much granularity. Your summary file might not be just enough. But one of these, with this dimension, is a balance file that has a breakdown by month. Great for trending, that type of analysis. But one thing I want to point out is, even with this type of universe, the logic, if you're trying to use your data warehouse for things like financial reporting and building income statements and balance sheets, and depending upon who you talk to, the data warehouse experts, some argue that, for financial reporting, as an example, you should do that against a transactional system. That's not what the data warehouse is intended for. Yet, JD Edwards customers that we talk to that want a data warehouse want it for financial reporting. So if that's the case, then that's still inside this semantic layer where you'll define things like, in this case here, it's an object for current year period actual amount, budget amount, year to date, quarter to date, inception to date. So this type of logic still is something that has to take place, because it's not, the data warehouse may be facilitating that to be more easily calculated. Those calculations still have to reside someplace. So that's the point, that the main thing is, just because you go with the data warehouse doesn't mean you can avoid other logic to build out